Hello everyone, welcome to my presentation. So the topic, what I will present today is gas pipeline operation management in Australia. So this is the pictures of pipelines, we know that. And so first, we have to know that why we will do this research. So we have to know the importance of pipelines. We know although we use new energies, we use clean energies, but actually the fossil fuel is still a necessary energy that we use every day that support the human society's running, development. So everyone use those energy every day in any types of formats. So we can see this data. Americans consumed 29% of natural gas and 40% of the oil, as part of our total energy consumption. Oh, that's really huge. So move to the next. So actually, we want to find a very efficient, a very safe, a very economic way to transit those energy. So the pipeline actually currently is the most safe and economic way for transporting those energy. So many people may heard like in some news, like whatever TV or newspaper, that sometimes the accidents of pipeline failure happened, but actually the possibility of this is really low. So you can see this data with over 2.4 million miles of pipelines. The number of accidents is less than a fraction of a percent. That's actually really low. But if those accidents happened, that's gonna be a disaster. So why we here? We want to get rid of all potential safety hazard and control the operation cost. That's why we're here. We want to make it better and better, safer and safer. So literature review. What kind of information have I found from the present literatures? So first, I found information from the pipeline failure analysis. This is really useful. This taught me what kind of reason lead to the failure, lead to the accident. So then it's the maintenance of pipelines and to the pipeline inspection techniques also. So then I found actually the corrosion is one of the biggest problem in the pipeline operation, during the lifetime of pipelines. So I move on. So to be more specific, I found the coating disbondment and the cathodic protection failures actually cause the corrosion. So you can see the picture. So and then the coating actually provides the physical protection. The cathodic protection actually provides the electrochemical protection. So those two come to a collaborative system, which is really useful for all of the pipelines, and it's really universal. So then this lead to my research question, which is, so in the condition of coating disbondment, partial disbondment, is the coating or the cathodic protection the dominant and the main protection from the corrosion? This I want to know. So this is my research design materials. So first, materials and samples preparation. So I want to use 4 steel pipelines with the same length, 30 cm for each one, and narrowing them with 1, 2, 3, 4 respectively, and covering coatings to pipeline 1, 2, and 3, and then punch 6 seam holes on the coating. So the diameter is 60 mm, but just in the pipeline 1. So sealing pipeline 1, 2, 3, preparing a soil sample, of course, from the seam area, and linking the cathodic protection appliances to pipeline 1, 2, and 4, and finally placing them in 4 sealed boxes, of course with the airflow, which can lead the air coming and covering the same weight soil. So this is the experimental process, increasing inside temperature and humidity to fixed value in every box, and opening the airflows and switching on all cathodic protection appliance. So after a time, so turn off all airflows and take out all pipeline samples and take off their coatings and clean them and dry them, and finally weigh them and comparing the weight difference from each one between them. So advantages of this research design. So by this experiment, we can know that in the condition of coating disbondment, so which part actually occupies a bigger proportion for corrosion resistance. So we can focus on this part. We can pay more attention and money to improve this part and to make the whole corrosion resistant system more effective, more efficient. And another is all of the materials and samples is really easy. It's really easy to get. I mean, it's easily available. It's cheap. So limitations of this research design, because the corrosion is a really long time process. Even though I've used many methods to accelerate the corrosion speed, like increase the temperature and humidity, but to get very obvious weight difference between the 4 samples, so the time span has to be long enough, which means I have to wait a long time to get those outcomes. And another is in the realistic situation, some other corrosions, for example, like from the content, like what does the pipeline is carrying, sometimes may influence the corrosion rate or lead to other outcomes. So this is so my research designs didn't simulate those situations. Yeah, so this is I think the biggest limitations. Yeah, thank you. That's all.